So next what we are having partial fractions method of partial fraction. We are having this type of integrals dx by x minus a into x minus b into x minus c, or some quadratic expressions ax square plus bx plus c divided by that means the denominator can be factorized into linear factors. Either distinct or repeated. So these are distinct factors, distinct linear factors, because here we are having x minus a, x minus b, x minus c, this type of factors. And what else we can have? Integration dx divided by say x minus a whole square into x minus b, or some quadratic expression divided by, okay, so this let us take differently. So the numerator is not a factor. The main factor is the denominator. So in these cases, how we can, okay, sorry. This denominator should be with repeated factors. So x minus p whole square into x minus q. That whole square is the repeated one. It can be a combination of repeated factors and distinct factors. Means one will be repeated with a square and the other one will be distinct to that. So these two types of functions we can have, and we have to see how we can integrate this. So previously we have seen, if you are having this form or this form, means distinct factors if you are having, then there is one way, and for the repeated factors we are having some other way. So let us see. Okay, this also can be there with another whole square, means two repeated factors can also be there. So one by one you will see. In case of these, we are separately writing the integrand like this. And whatever we are doing now, it's not a part of integration, it's a part of simplifying this expression. It's not a part of integration. Integration we will do later. First we are looking at how we can write it simply. So that we can do like this. Whenever this type of expression is there, we can write it as capital A1 by x minus a plus capital A2 by x minus b plus capital A3 by x minus c. So each linear factor can be written like this. Okay, whatever the numerator is. For this one also we are doing the same thing. There is a quadratic expression here, but still we are not going to take anything in the numerator. Here the numerator in the right hand side, it should be only a1 by x minus a1 by one linear factor, a2 by one linear factor, a3 by one linear factor, where a1, a2, a3 are unknown constants. Unknown constants. আপনার এসছো?
হ্যাঁ স্যার,
কোথায় গেছিলে?
একটা কল চলে এসেছিল।
আচ্ছা, so this is the thing. So we can write the distinct linear factors like this. So whenever this or this type of integrals will come, we'll consider it like this and then do the LCM in both the sides. So if we do the LCM here, what we will get? A into a1 into x minus b x minus c plus a2 into x minus a x minus c plus a3 into x minus a into x minus b whole divided by that LCM. So from cancelling out from both the sides, we can see that we will get only this expression 1 equal to a1 into x minus b x minus c plus a2 into x minus a x minus c plus a3 into x minus a x minus b. Now one by one we will put the values of x as a, b and c. So when you are putting a, x equals to a, only this factor will be there and this two will be 0. So you are getting the value of a1. When you are putting b, this factor and this factor will be 0. You are getting the value of a2. And when you are having, when you are putting x equals to c, the first two terms will be 0. And the third from the third term, you will be getting the value of a3. So this is the integrand, and since all the factors are linear factors, distinct factors, we can apply this way. So the integrand is this, and we can write the integrand as this one as we have seen, a1 by the first factor plus a2 by the second factor plus a3 by the third factor. Now we are doing the LCM. So this line is coming a1 into x2 minus x3 plus a2 into x1 minus x3 plus a3 into x1 minus x2, and the denominator is this, the LCM one. So we can just cancel out both the denominators here, and this will be the equation. X minus 5 equal to a1 into this, a2 into this, a3 into this. So the factors are x minus 1, x minus 2 and x minus 3. That's why we need to put the values of x as x equals to 1, x equals to 2 and x equals to 3. So now we are putting them here. So putting x equals to 1 in this line, but we are having 1 minus 5 into this. Since x equals to 1, we are putting the second and the third term. It is carrying one factor x minus 1, so it will be 0. In the same way, okay, so for the value of x equals to 1, we are getting the value of a1 only, because this factor will be there only. The other ones will be vanished. So from here we are getting the value of a1 as minus 2. In the same way, we are putting x equals to 2. So it's 2 minus 5 equals to this. And since x minus 2 is there in the two terms, the first one and the third one, these two terms will be vanished when we are putting x equals to 2. So a2 we are getting from this line, a2 equals to 3 we are getting. And the third one, putting x equals to 3, x minus 3 is in these factors, these two terms. So putting x equals to 3, these two terms will vanish, the third one will be there. So 3 minus 5 equal to this. So from here we are getting the value of a3 as minus 1. So now if this is the thing, we can put these values here in this line. You need to write it separately. I'm just overwriting it. So the value of a1 is minus 2, value of a2 is 3, value of a3 is minus 1. Till now no problem is there. So now see, the expression was so much complicated for integrating, but what we have done, after that we are getting such a simple expression, these three terms. So after simplifying the integrand, our task is to integrate both the sides. So from here we can write, therefore integral x minus 5 dx divided by x minus 1, x minus 2, x minus 3 is equals to minus 2 I'm taking out of the integral. So dx by x minus 1 plus 3 dx by x minus 2 minus 1 dx by x minus 3. Three simple integrals are there. So we can just put the formula. As we know, dx by x is log mod x. So clearly here, for x minus 1, there will be no change. No substitutions are required. So we can directly say it is log mod of x minus 1 plus 3 log mod x minus 2 minus log mod x minus 3 and plus c. So easily we can see, after applying the properties of log, we can see it is log x minus 1 to the power minus 2 log x minus 3, x minus 2 to the power 3 and log x minus 3 to the power minus 1 plus c. So log of mod x minus 2 whole cube divided by x minus 1 whole square into x minus 3.
Sir, how the power is coming, sir? Can you one explain,
Log
sir?
property of log
Power term.
in log x equals to log of x to the power m. This formula we are applying. So minus 2
Yes, sir.
log of this, it is minus 2 is coming to the power. Here this 3 is coming to the power. Here minus 1 is coming to the power. And then we are applied this formula, log a plus log b equals to log of ab. So
Yes,
the
sir,
first
got
and
it.
the third term are having negative power, so they are coming in the denominator, and this is having the positive power, so in the numerator. Okay.
Yes, sir, got it.
So this method is called the method of partial fractions. So what we are doing here, if this type of integrand is there, where the denominator is a product of linear factors, repeated or unrepeated, we can write the linear factor in a simple form, and then we are going to integrate it. So let us see one more problem. Say dx by x minus 2 whole square into x plus 1. So as we have seen for distinct factors, that every distinct factor will give a term like a1 by x minus a. So what is for repeated factors? For repeated factors, since here this repeated factor is there, x minus 2 whole square, we need to take one term like this, a1 by x minus 2, and a second term due to the whole square, we need to take another term like this, x minus 2 whole square. And then the third term for linear factors, distinct factors, we are having this x plus 1, so a3 by x plus 1, and constant divided by x plus 1. So for every linear repeated factor, this type of terms will come. If it was x minus 2 whole cube, then we should take it like a1 by x minus 2 plus a2 by x minus 2 whole square plus a3 by x minus 2 whole cube, and then one a4 by x plus 1 will come. So depending on the degree of repetition, this terms will come. If it is 3, so we need to take x to the power 1 to the power 2 to the power 3. If it is 2 to the power 1 to the power 2, in this way. Starting from power 1, we need to take all the terms up to the given power. Okay.
Yes, sir, got it.
And whatever other factors are there, for them the rule is the same. Now suppose it is like dx by x minus 2 whole cube x plus 1 whole square, or both the factors are having a square power. So then for both the factors we need to write the powers like this. X plus 1 a4 by x plus 1 whole square. Okay, so this is the way to take the expression. Sorry. One thing I have done wrong, that this will not be there. This will, the integration sign will not be there here for this thing. So this is not a part of the integration, this is the part of simplification. That's why we cannot give integration sign here. You do the simplification and then you take the integration sign in both the sides. So suppose the integration is like this, and so we are writing the integrand like a1 by x minus 2, sorry, it is whole square, a2 by x minus 2 whole square, a3 by x plus 1. The same thing we'll do. We'll take the LCM and take the sum. So for A1, so we are having x minus 2 into x plus 1. For A2, x minus 2 whole square. So only x plus 1 will come. And for A3, it will come as x minus 2 whole square. So the denominators are cancelled out. So we can write it like 1 is equal to A1 into x2, x minus 2 into x plus 1 plus A2 into x plus 1 plus A3 into x minus 2 whole square. So now the same thing, x minus 2 and x plus 1 are the factors. So we need to put the value of x as 2 and minus 1. 2 and minus 1. So just like putting x equals to 2, RHS is 1, and here x equals to 2 we are putting, so only this term will be there, A2. The other two terms will vanish. So it is 2 plus 1. That means we can say A2 is equals to 1 by 3. Putting x equals to 1. Sorry. The factor is x plus 1. So if we make it 0, we are getting x equals to minus 1. So we need to put x equal to minus 1 here. And we can say 1 is equal to, this 2 will vanish and we are getting the value of A3. That means it's minus 3 whole square. So A3, sorry, this will be A2. So A3 we are getting as 1 by 9. So A2 and A3 are done. And also we don't have any other value of x1 to put. Now one very important point, this line what we are writing here, this is an identity. Identity means this relation is true for every real number. Whatever value of x you can put, it will be same. Because A1, A2, A3, these are unknown constants. For different values of x, different values of A1, A2, A3 can be obtained. So it is not like fixed values are there and we need to find only fixed values of x1, x2, x here. Since the coefficients A1, A2, A3, these are unknown, we can take any value of x and put here to get any value of A1, A2, A3. So why we are putting those factors only? Because it is easy to make factors 0. For easy calculation, it is required. That's why we are putting those values. But now see, all the possible factors we have done. X minus 2 and x plus 1 are the factors. So 2 and minus 1 we have done. So we need to take some other value here to find the value of A1. And the simplest value will be to take x equal to 0 here. Any other value we can put. For simplicity, we are taking x equals to 0. So here we can write 1 is equal to A1 into minus 2 into 1 plus A2 we have already found. So it is 1 by 3 into 1 only. And for A3 also minus 2 square. That means it is 4 by 9. So from here we can say minus a1, minus 2 a1 equal to 1 minus 1 by 3 minus 4 by 9. So if you calculate it, 9 minus 3 minus 4, so 2. That means you are getting a1 as minus 1 by 9. So this is the way for the repeated factors. That means when you are having repeated factors, you may put one value other than the factors we are having. You may put x equals to 0 then, or some other value depending on the factors. So from here, we can put the values of a1, a2, a3 in this line and simply write the integrand. So for a1, we are writing minus 1 by 9. For a2, we are writing 1 by 3. For a3, we are writing 1 by 9. Done.
Yes, sir. Done.
The next thing is very easy. See, the integration part is very easy. So we can write dx by x minus 2 whole square into x plus 1 as minus 1 by 9 integration dx by x minus 2 plus 1 by 3 integration dx by x minus 2 whole square plus 1 by 9 integration dx by x plus 1. If this is the thing, we
Yes.
can integrate it easily. Minus 1 by 9 log mod x minus 2. Now here, what is the integration of this? X minus 2 whole square means it is the integration of dx by x square, means x to the power minus 2. So minus 2 plus 1 divided by minus 2 plus 1. So it should be x to the power minus 2 plus 1 divided by minus 2 plus 1 means minus 1 by x. So here it should be minus 1 by 3 into 1 by x minus 2. Just instead of x, we are putting x minus 2. And here it is 1 by 9 log mod x plus 1. Then the integrating factor. So the first term, taking 1 by 9 common, first and third, we can write as x plus 1 by x minus 2 minus 1 by 3 into x minus 2 plus c. So this is the solution.